Okay, so we're going to start looking at combinations. So what we've done so far is looked at permutations, which is an arrangement, or pretty much when you have a group and you're selecting a group, but the order that you selected in matters. You're arranging a line, you're selecting a group of numbers for some type of code, so something where order matters. So now in combinations, we're going to be looking when you're selecting a group and order doesn't matter. So for example, if you were to select a pizza and there was 40 toppings and you selected 2 of those toppings, it wouldn't matter which topping you selected first. It'd be the same pizza. So combination, order does not matter. Permutation, it does matter. All right, we'll also look a little bit at this formula. This is on your formula sheet, so we will be referring to it in this lesson. So the first thing we're going to do is we're actually going to find the combination button on our calculator. So you're going to take your graphing calculator out, and we're going to type in 10, choose 3. So 10, and then I'm going to go to math, over to probability, and I'll choose option 3. Choose 3. So what that 10 choose 3 represents is, say you have 10 items and you're choosing 3. Okay, so there's 120 different ways that you could choose 3 groups of items out of that 10 items. Okay, so I think I ended up with 120. So I'm just going to write that in there. Oh dear, it moved. 120. If you were to type 9, choose 4, this is another way to write it, although that line shouldn't be there. It's not a fraction. Okay, it's a column. All right, that would be the same as 9, choose 4. So it's just another way to represent a combination. Try to type that in your calculator. You should end up getting 126. Okay, so we're going to look at some examples now. So the first example we're going to look at is 3 students from a class of 10 are to be chosen to go on a school trip. In how many ways can they be selected? So out of 10 students, we are choosing 3. So we're going to go to our calculator and we're going to type 10 choose 3, which actually we've already done. Okay, it gives us 120. Now what I want you to do is I want you to try to type 10 choose 7 and see what it gives you. So let's try 10 choose, oh, whoops, I wrote the 10 in the wrong place again. So we're going to probability, option 3, 10, choose 7, enter. So notice how 10 choose 3 and 10 choose 7 both give us the exact same answer. This actually, we can prove that using the formula here. So remember that formula that I had on the last slide was n factorial over n minus k factorial, k factorial. Okay. So if you were to do 10 choose 3, your n value would be 10, and your k value would be 3. So it would look like this. So you would have 10 minus 3 is 7 times 3 factorial. If you were to do the exact same thing, and I'm going to write on the bottom here, and use the 7 instead of the 3, this is what it would look like. 10 minus 7 is, of course, 3. So notice how these two are the exact same solution. All right. We're actually skipping this section here with the Lotto 649, and we're going to move on to the next question. So the Athletic Council decides to form a subcommittee of 7 council members to look at how funds should be spent on sport activities in the school. There are a total of 15 Athletic Council members, 9 males and 6 females. So remember, we're choosing 7. There's 15 total members, 9 males and 6 females. The subcommittee must consist of exactly 3 females. Determine the number of ways of selecting the females. So we could write 6, choose 3. So if we type 6, choose 3 in our calculator, we end up with 20. For the males, we can type 9, choose 4. If we type 9, choose 4 in our calculator, we end up with 126. The subcommittee. So because there's males and females on the committee, okay, we would multiply. So we would have 20 times 126. So we're multiplying these two. And you would end up with 2,520 in total. So now it says, in how many ways can the subcommittee be selected if Bruce, the football coach, has to be included? So what we're going to do is we're going to write this out. We'll start with the females. So the females didn't change. I still have 6 females and I still need 3 on the committee. However, the males has. Because Bruce has to be on the committee, now instead of 9 males to choose from, I have 8. Because Bruce already has one of the 4 spots, instead of having 4 spots to pick, I have 3. So this is what my new equation would be. Okay, so go ahead, try typing this in your calculator. You should end up getting 1,120 if you type it correctly. All right, so the next question. The student council decides to form a subcommittee of 5 council members to look at how funds should be spent on the students of the school. There are a total of 11 student council members, 5 males and 6 females. How many different ways can the 5-member subcommittee be chosen if there are no restrictions on the number of males or females? So we need 5 on our subcommittee, so I'm going to underline that. There's 11 kids on the student council. So again, this is a combination because it doesn't matter the order that I pick these students in. So I'm going to write 11, choose 5 because I'm choosing 5. So go ahead, type that in your calculator. You should end up getting 462. The next question says exactly 3 females. So if there's 5 on my subcommittee, okay, and I have 3 females, I'm choosing, there's 6 to choose from, so I'm choosing 6, choose 3. So I'm choosing 3 out of those 6. And I also have males on the committee. So out of those 5 males, I'll be choosing 2 to have that 5-member subcommittee. So now I'm going to go ahead and type this in my calculator. 6 choose 3 times 5 choose 2. You should end up getting 200. All right, so last example on this question, or last question on this example, at least 3 females. So that word at least changes pretty much the entire question. So now I have a few different options. I could have a committee with 3 females, okay, which we already found was 200. So I'll just write 200. Or I could also have a committee with 4 females. So if my committee had 4 females, okay, the equation to represent that, now I'd have 6 choose 4. And out of the males, I'd have 1 less male that I'm selecting. So I'd have 5 choose 1. Or I could have a committee of all 5 females. So in this case, I would be typing 6 choose 5 on my calculator. So let's try 6 choose 4 times 5 choose 1. If you type that in your calculator, you should be getting 75. Now let's try typing 6 choose 5. If you type that in your calculator, you should get 6. So now remember, we have 3 females or 4 females or 5 females. So these 3 numbers, to figure out the total amount of committees that have at least 3 females, I'm going to add them because it's an or question. So I'm going to take my 200 plus 75 plus 6, and my final answer ends up being 281. All right, so we're actually going to skip this question with the cards, and then we're going to go into these last, and we're going to skip this one as well, sorry. And we're going to go into these last 2 diploma questions. So here it says, at a meeting, every person shakes hands with every other person exactly once. So the first question you have to ask yourself, how many people, okay, would be in handshake? So, okay, what group would that be? That would be a group of 2, right, to shake hands. So really we're making groups of 2 here. if there are 36 handshakes in total, how many people were at the meeting? So this time they gave us the answer. So we have 36 as our answer. Okay, so we're looking for how many people are in the meeting. And we know we're making groups of 2. And in total, there's 36 different handshakes because everyone in the room shakes hands with every other person. So we're looking for that missing number there. So you could do this by guessing and checking, but we're going to actually do it algebraically using that formula that we put on the board that I put on the very first slide. So I'm going to write that down. Oh, I'm going to go double check it. What was it? N choose K, N minus K, K? Okay. Okay, so for this example, our answer is 36. Our N value, that's what we're looking for. And our K value would be 2. So all I've done is fill in the formula. So now there's not a whole lot I can do from here. I know that 2 factorial is just 2. So I can get rid of that by multiplying it to the other side of the equation. So I'm going to multiply it to both sides here to cancel it out. So 36 times 2 is 72. So now I have 72 equals n factorial over n minus 2 factorial. So from here, we want to get rid of that factorial symbol so that we can solve this. So we've done questions like this on an earlier lesson with factorials. So we want to get rid of the factorial symbol. So we're going to have to take the bigger factorial, which is n, and expand it out. So n minus 1, n minus 2. The reason I'm expanding it is because I want to be able to cancel out those factorials, but I need the same term in front in order to be able to cancel it out. So now I can cancel that n minus 2 factorial, which leaves me with n squared minus n. And from here, okay, I can bring the 72 to the other side. So I'll subtract it. And now I can factor. So 2 numbers that multiply to give me negative 72 and add to give me negative 1 are minus 9 and positive 8. So from here I'll solve. So n equals positive 9 and n equals negative 8. All right, so you can't have a negative amount of people in a meeting. Actually, you can't have any negative factorials. We kind of talked about this a few lessons ago as well. All right, so that means this n minus 8 would be an extraneous root. So my only solution is that n equals 9. So that means there are 9 people in the meeting. All right, we'll look at this last question here. How many different 4-letter arrangements, so we're making a 4-letter arrangements, are possible using any 2 letters from the word smile? So we can use any 2 letters from the word smile. And any 2 letters from the word frog. So first we have to choose our letters. So this would be a combination. So out of these 5 letters in smile, I'd have to choose 2 of them. So on my calculator, I'm going to type 5 choose 2. All right, so that ends up giving me 10. So I know 5 choose 2 equals 10. Now for frog, out of these 4 letters, I also need to choose 2. So on my calculator, I'm going to type 4 choose 2. And I end up with 6. So now the 10 represents the 2 letters, the 2 combinations for the letters I choose, or the combinations when I'm choosing 2 letters in the word smile, and the 6 represents the amount of combinations when I choose 2 letters from the word frog. So I am choosing letters from smile and letters from frog. So which is why I'm going to multiply these 2 numbers. So this represents all the possible combinations of letters that I could have in this 4-letter arrangement. But now I need to arrange those 4 letters. So I'm going to need to times this by 4 factorial. So the 60 represents the total amount of combinations of letters that you could have. The 4 factorial represents you arranging those letters. So if we type that in our calculator, we should end up with 1,440. So that would be a more difficult concept in 30-1. All right, that's why it's a standard of excellence, because we're choosing and arranging, which is why it uses both combinations and permutations. We'll look at the difference between combinations and permutations in the next lesson.